and welcome to another edition of the Code Remix Weekly. As usual, I'm your host, Tim Tebake, and my co-host, Sam, isn't here, unfortunately. He's in sunny California, attending the Swamp Up conference, where he's just telling folks about OpenRewrite and Modern and what you can do with all of those. So, unfortunately, we can't have him on the show. No one to ask me about my hiking for the past weekend. But I get to also similarly fly out tomorrow morning. So I'm leaving right after this episode for the airport here, just to be able to share the word of what we do in London. So with that, you'll also only be seeing Sam next week. So I get to return the favor of having to run the show by yourself as the other is out. So with that, we're going to take you through a couple of quick updates on things new in the past week. And of course, every 2 weeks we do a release on Wednesday, and we did yet another today. And quite excited for this one because we added support for Java 25. So if you're looking to upgrade next week, the next version is coming out on the 16th, which would be Tuesday next week. Then we already have support for you with recipes to be able to migrate to the newer Java 25 version, as well as parser support if you're already on Java 25 to be able to maybe parse those pesky unnamed variables that you can now adopt in bulk using the recipes that we already have available. Now there's 2 features still in the waiting list that, with regards to parser support, so don't go running off and adding module imports or adding unnamed classes when you go to adopt Java 25. But pretty soon we already have the PRs ready. We should be able to support those as well. So know that next week you can just keep going as you always do, upgrading to the latest version and get full support from all of us here at OpenRewrite and Modern. And we've also added some fixes for parsing records and enums, so that should be improved, as well as some minor fixes for HCL, Groovy, TODO, and YAML over the past 2 weeks. Now, some folks will be looking forward to upgrade to Spring Boot 3.5 and Spring Cloud 2025. Those recipes are now available in the open source side, thanks to a contribution from a community member. And then those recipes, they will mostly use the declarative style that we have. So they're going to help you upgrade your dependencies, help you upgrade your properties, as well as some minor things here and there. And of course, at Modern, we have recipes that go beyond that, picking up further deprecations, as well as recipe modules like Hibernate 6.5 and beyond that you can get if you have access to the Modern tool suite. And we also added some small recipes for Gradle 9 upgrade, and a 9.1 in particular, where they're going to deprecate the map notation for dependencies. And we already had a recipe contributed by Jente to be able to migrate you onto the string concatenated versions. And you can now leverage that recipe as you upgrade to Gradle 9.1. Now, also very new is that we have 2 completely new recipe modules here at Modern, where if you want to upgrade your Kafka applications or you want to upgrade your Elasticsearch applications to take that client 9 into account, then we now have modules to help you there. So hope you look forward to all of those changes. And as always, the releases are already available for you through Maven Central. And if you want to dive deeper into the changes, you can go to our docs, as always. I'll post the links just now. And there you can see that we have a ton of new recipes available to you, like I said, to upgrade Hibernate, Elastic, Kafka, and many, many others as well. I think we added some 68 new recipes in this particular release, including those Spring Boot upgrades, Java 25 upgrades, and all of that available to you. So with those full details, go ahead and browse them and let us know what you think. And we also have published 2 new blogs this past week. So one of them is specifically on writing recipes using AI, in this case leveraging Claude Code, as many of us do here at Modern, to, in this case, do a completely new migration, going from JBoss to Jetty, and then taking you through the process of how you would set up AI to, in a structured way, work through the steps necessary to develop those recipes, and then judge the quality of those recipes when you leverage the tools we have to verify at scale that these work well. And then maybe then you can, within your own company, similarly achieve the use cases new to your organization. So have a look at that blog if you want to get inspired on how to do exactly that. And then beyond that, we also have a blog post on using the Modern CLI version 3.45, where we have emphasized new ways to run that CLI based on a local CSV file. Because we want to make it easier for folks to be able to check out projects, synchronize projects, run recipes, and share those with colleagues. And all of that can now be done using the CLI in a very convenient way. So if you want to learn more about the details and exact changes there, then definitely dive into that blog post to learn all about what is new. And hopefully you'll be able to access that maybe as part of our online trainings that we do to be able to use these tools effectively within your organization. Now, like I said before, we also do monthly online trainings. We did one last week, which was a getting started training for the European time zone. And we're going to do a advanced training next week, also in the European time zone. For me in the Dutch time zone, Amsterdam, that would be from 1 to 5 p.m. And if you want to get involved there, then you can sign up and you'll be able to get a link to the Zoom and be able to learn more details about some of the topics, specifically going beyond those first basics. So looking forward to that one next Thursday. If you want, then hope to see you there. And then finally, something that is new is that we now have a careers page at Modern. So if you want to join the company and help organizations upgrade, then definitely have a look at that page for some of the positions that are open currently. Now, I've been here for a while. I remember when it was invite only, and now we're very excited to have grown to the point where we actually have a careers page for you folks that are interested in joining. So with that, I hope that you explore that, maybe see if that aligns well with what we're hoping to do, and then maybe we can see you on internal calls all the same. Then with that, we're going to stop sharing these tabs. We're going to look at the in more detail in the topic specifically for this week. And for this week, we have a exercise where we're going to look in more detail at scanning recipes. As you'll maybe recall, last week we looked in detail at using data tables. This week we're going to look at scanning recipes unrelated to data tables. And we're tackling these two topics separately because we find that sometimes folks struggle a bit with conflating these ideas, thinking that you need a scanning recipe to produce a data table or vice versa. Whereas in this case, we have an exercise where we're going to, in the same problem space as last week, look at to-do items across your code base. But where last week we produced a data table that you can export using the Maven plugin and the Gradle plugin, as well as the Modern CLI and Modern platform, we now are going to look at a scanning recipe which produces a separate file within your repository containing those same to-do items. And of course, you can then run that recipe repeatedly to be able to keep that file up to date, such that you always have an up-to-date list of to-do items within your repository. So with that, we're going to open my IDE and we're going to take you through the exercise that we have there. So for this one, I'm going to share the recipe that we have, and there's a starter here in the Rewrite Recipe Starter. It's a project that we use to showcase a lot of the recipes available to you. And if you wanted to similarly have a look at this particular class, then I'm going to share the link with you to this file in the chat. Now, I hope this is sort of visible on your end. I don't have Sam to yell at me if it's not yet big enough, but in this case, it's readable on my end, and I hope it goes the same on your end as well. Now, what you're seeing here is that we have a placeholder. So we have a track Java to-dos file, and we've outlined the steps that we want to take for this particular recipe. So we want to have this be a recipe that looks across all of your Java source files, and then creates or updates an existing file within the root of your repository with a list of to-do items that need to be collected. So that is what we set out to do here. And then of course we already have the tests associated with this particular recipe. And here you can see that we have pretty much the same test as we had last week. But we have a couple of different to-do items. Those will be stored in the space, as you'll recall. But in this case, we're going to generate a new file that initially does not exist. And then after running the recipe has a header as well as a list of to-do items. It's very straightforward. And of course, we can have the same, but then have it already exist initially. Slightly different case here. And then beyond that, also, here we have a test that it shouldn't update anything if it already has the right content. Now, we can run these tests. We can see that they currently fail. And then from there, we're going to look at how to implement each of these. So in this case, we're going to enable the first test, and then we're going to look at the implementation. And what I want to do is I want to take you to a bit of the docs that we have on producing scanning recipes. And for that, I'm going to just link the doc page that we have on scanning recipes, such that it should all be available to you. If you go to docs.openrewrite.org/concepts and explanations/recipes, there is an anchor there for scanning recipes in particular. Now, scanning recipes, as I said, they allow you to look across files in an initial pass before calling out two new phases. The first phase is that it can curate a new file, or it can visit existing files and make the necessary changes there. So where regular recipes, non-scanning type, they don't have any of these generics, they don't have any other phases, but the scanning recipes in particular, they execute in 3 distinct phases. One, that scanning approach, then a generation phase for new files, and then an update phase for existing files that you might want to visit. And now we're going to implement each of these steps. Now, first you want to take note of the generic argument here, which we have, which is a truck Java to-dos file inner class for to-do comments. This is the state that we're going to build up when we execute this recipe, and then use that state as we come to generate new files or visit existing files to make any updates there. Now, you can use any class here as long as it is serializable, I believe. And in this case, that state will be passed around as you visit different source files, and then collectively be built up in this way. And you can see that passed in here in the to-do comments, and you'll also see that when we build it up, when we go through the scanning phase, and then the generation, and then the modification. Now, typically, you want to, in your scanning recipes, take note of whether you have multiple projects, like a multi-module project where you have a project at the root and then different sub-modules, and maybe not have a boolean in your accumulator class that you have here. But in this case, we've decided that for the entire Git repository that we have, we're going to have one to-do file at the root, as opposed to many individual to-do files across the different modules. So that's one thing to take account. Otherwise, what you could do is have a map here of a Java project linked to a Boolean or other way of tracking to-do items. Now you'll see here that we have overridden a first method that is unique to scanning recipes, where we're going to say, I want to get the initial value of the accumulator object that we're going to use in our scanning recipe. And in this case, that is just a plain new instance of to-do comments, which we will update as we go through the scanning phase to include additional details. Now in this case, then the next step is to implement the scanner that we have. The scanner will do that first pass and store any data that is wanted on that to-do comment instance that it gets passed in. So note that we get an instance returned by get initial value passed into the scanning phase. And then from here, we're able to make any changes that we want to maybe set that found to-do file boolean to true, or add items to the to-do items. So with that, we're going to implement the first method that we have in our tree visitor. And let's first try to set that found to-do file to true when we've actually identified it. And for that, it's a very simple implementation. We're going to override the visit method, which gets passed in a tree. And from that tree, we're going to look to see if it is actually an instance of a source file. If not, we have nothing to do here. We can do that here if it is not an tree instance of source file, and then we want to return the original tree. So beyond this, we know that it is actually a source file, so we can just assign it. The source file is a tree, and then from here we're going to say if the source file path ends with todo.markdown, we'll have found the actual path that we're interested in. So the source file, that's a bit much. Typing assistants are helpful, but not always. If this ends with do.markdown, then we say we have identified the element that we're interested in, and we can do it in this way. So this is enough to identify the existing to-do file, and in that case we can use that information that it has been identified when it comes to potentially generating a new file or holding off on producing any conflicts there. So that's helpful in itself, but we also want to check to see if the source file that we're looking at might be a Java file, and if it is a Java file, we want to use a similar visitor as we had last week to identify individual to-do comments within that file. So we're gonna, in this case, check to see if the, let's first create a Java ISO visitor to extract those elements of the to-do items. And say, let's not yet implement the details here. Also, those methods that are generated didn't exist. So we're going to say if extract to do that is acceptable for the source file that we're looking at, using the context that we have, then we want to visit that visitor that we have to potentially extract some to-do items and add them to our list. So for now, we haven't implemented it just yet, and for the implementation I'm just going to copy and paste the implementation that we had last week, with the slight modification that we're not going to insert a row, but we're merely going to add an item to our accumulator to-dos. So in this case we have our visit space method that we override. We're going to again look at any comments that we find on the space. We're going to ignore for now that there might be Java docs with to-do items within them, and then only look at the text, and if it contains a to-do, then we have some text that we're interested in, and we're going to add that to the list of to-do items that we have stored in our accumulator to-do comments right here. So this is our scanner fully done. You'll see it's just a couple of lines to be able to handle different types of files. In this case, it is a plain text markdown file that we're handling, and whereas in this case it might be a Java file, and that is very much true for scanning recipes, especially when you're using a tree visitor, which will be handed any file within your repository. So keep that in mind. You might see different types of files if you want to evaluate different types for your particular recipe. And we see this pattern, for instance, when it comes to Gradle recipe upgrades, where you want to look not just at the build file that you have, which might be implemented in Groovy or Kotlin, but you might also want to take into account those TOML files or those properties files, because similarly you'll need to evaluate their state as well to build up some knowledge to make the correct change when it comes to maybe upgrading a dependency in one of the 15, 16 different ways you can do so with Gradle. So with this in place, we now have our state going to be populated in the first phase of our scanning recipe. So we have this get scanner, which gets called by the recipe execution, and then from there we'll have that state populated when it comes to the next two phases. Now the second phase that we want to execute is that we want to evaluate whether we should potentially create a new plain text file to hold our to-do comments. In this case, we're going to override the get, let's see, name the generate method, and you'll see that we get similarly passed in the to-do comments instance that has been pulled up in our scanner, and then from there we don't necessarily have to call super.generate, because I think that is just an empty list of items that we expect to be returned. And then with this we can very simply say I want to generate a new plain text file, but only if necessary. So what we're going to do here is we're going to say empty list, and we're going to use a static import, and we're going to say if acc.found to do file, then we want to actually return that empty list. And if we haven't yet found a to-do file that we want to modify, then we want to generate a fully new file. And you notice that the signature of this method is a collection of files that you might generate. In my case, I'm interested in generating just exactly one file. And we can do so by using any of the parsers that we have. In our case, we're looking to create a plain text file, so we'll use the plain text parser to generate that new instance. So we're going to do so by calling just return, and we're going to say plain text parser.builder, and we say just build it, and then we're going to say parse. There's a slightly different parse method that I want to use, which is simpler, where we can pass in a source that we wanted to parse. It's okay to start this file out empty, because we're going to have to change it anyway later on when it comes to overriding potentially the content of existing files. Now we want to create some, make sure that when we create this file that it actually has a source path. For that we use this map function, and in this case we do need to, I think, cast it, because, the path expects an actual path, so our helpful suggestions here aren't really that good. Path.get to-do.markdown. And now we're very nearly there, because now all we have to do is return this collection as a, return this stream as a collection. So we say .collect, collectors to list, and use a static import. And at this point, we get complaints that it isn't yet a source file that returns, but just a stream of objects. So we're going to add a cast here. And now we have our second phase of 3 implemented for our scanning recipe. So we're building up that initial state of whether the to-do file has already been found. And if it has not yet been found, only then do we generate a new empty file for us to then populate in the third and final phase to be able to have a list of to-do items populated in a new file for this recipe. So then here we want to override the getVisitor method. And this is where you want to take note that this is a scanning recipe. You want to specifically override the getVisitor method that has a to-do comments instance passed into it, as you probably know this pattern by now. And from here we're going to make changes to only existing plain text files if they have that particular path that we're looking at. So we're going to, instead of the super visitor, which is just going to be empty again, we're going to say we want to return a new plain text visitor using an execution context as the argument. And we're going to say I want to visit the text of any file that I found. We're going to do the familiar initial assignment of the super call here. I don't think it's crucial to do so, because I think this is mostly just going to visit the markets and the snippets, which we're not that interested in here. And then we're going to say, well, if this is the type of file that we're interested in, then only do we want to make changes to the content. So if it's not a get source path that we're interested in, then we're just going to return the potentially updated plaintext T here, and then be done. So beyond this point, we know that the file that we're looking in is actually the file that we're interested in. So we're going to curate the file with an optional header, which is an argument to the recipe that you see here, as the start of our to-do list that we want to create. And then beyond that, set that content in the plaintext that we have. So we're going to do here return the initial file that we might have. It might be an existing one, or we're going to overwrite the content. And I'm going to say with text, and we're going to override it with the content that we are still to create here. Now the content will be a concatenation of either an header that was explicitly passed in, or a default header that we've said that we would add if none is provided. So for that, there's a very simple way to do so using a prefix. And we're going to say use the header that is our argument, or this one. And if not, then we're going to add this to the content that we have. So in this case, we're going to expect this to be the collection of the to-do items that we have within our accumulated state of to-do comments. So we're going to say we're going to acc.todos.stream, and we're going to map that stream of to-do items that we found, because we want to do a very simple trim operation here. Then we're going to say we're going to collect, and we do a collect in the collectors.joining. And we're going to say that we want to separate each of these with a new line. And then beyond that, there's an equals sign missing here. And we also want to have a prefix of that potential prefix with a slash n, and a suffix ending with nothing at all. Come on. And now we have our content created. We're using the prefix of a header, and we have the third phase of our scanning is complete. So starting from a scanner that looks at multiple different types of files to build up that state, and then potentially create a new file where necessary, such that in the third and final phase we can visit a plaintext file with that to-do markdown extension, and then set the content if it isn't already. You can immediately see here why it is not necessary to similarly create the content here already, because we're just going to visit those files anyway. There is no need to do this. Now, if you don't have a need to handle existing files, then you can remove this and of course set the content here and here only. But we find it is typically helpful to do that handling anyway. So now let's see how we did. We have implemented everything. We have our tests, and we're going to run the first one. We're going to see if this actually works. I can tell you, I never like live debugging. So we're going to see here, and we can see that the expected that we have here with a new line at the end isn't the exact same as the actual that we got, because in this case there is a new line at the end. So let's see if there is some special handling here. I think there is a option already on a no trim, saying that we don't want to have this trimmed. So let's see if we can similarly reflect that here. And now it's all passing. So what we have is we have our recipe actually doing what we said it would. We're going to find these individual to-do items. We're going to create a new header when using the header that we've passed in. And then each of those three to-do items, which of course can then be crossed off as you work on your code, and the next recipe run will see that updated. Let's see if any of the other tests similarly pass by now. And we're going to run them in one go. So this one has already an existing to-do item. So this one is failing because it is adding a new line at the end of the file. That is just plain odd. And now all three of these are working. So we have a test here where, in this case, the content was already exactly as it should be, and nothing has changed. There'll be a validation here to say that we're not making any changes to this file, just based on this with text, which actually does a comparison to see if the text is the same as the text passed in, and if so, and only if that differs, creates a new instance. So with that, we have all three phases of our scanning recipe implemented. We of course hope that this is helpful for you if you want to learn specifically about writing a scanning recipe that looks across different types of files, builds up some knowledge based on those files, and makes targeted changes in either generating a new file or updating existing files based on the knowledge that you have collected. So that is all I wanted to show you. So we're done with that. We're going to stop sharing. And I'm going to say thank you all. I'm going to rush to the airport. And I hope that you'll all join Sam next week when we take a third look at this topic of to-do items, but then using the concept of traits to look at not just different types of files, but try to abstract over different file types to handle all comments across those different languages the same when it comes to, again, creating a file or creating a data table using the traits to abstract across all of those. So I'm looking forward to that one, watching it from the plane, probably somewhere. And then with that, I hope to see you all very soon. Cheers. Thanks all.